helping me out behind the scenes. He is going to act as our narrator slash facilitator, and you are going to act as my fellow lunar astronauts. So,
hi, this is Lee Furseth. We're from the Headwater Science Center today. We're doing a really special project. The special project is for two purposes. We are documenting the Luna adventure, and Luna stands for moon. So this was the moon project that we had up on our exhibit floor for a while, about 4 or 5 months. We had it up on our floor over the last year. We have just recently moved this one back into storage, and we might take it out later. That's not the point of what I wanted to talk about today. The point is that this project right here was from a generous contributing partner named NISE, the National Institute for STEM Education. I like to think about that name, NISE, as being an acronym in an acronym. This is an acronym inside an acronym because it's the National Institute for STEM Education, and the National Institute for STEM Education, that's STEM, science, technology, engineering, and mathematics. So this is Angie, and Angie is the Director of Visitor Experience. So every time you have a great time at the Headwater Science Center, you should say, "Thanks, Angie, you did a great job today." And she is showing the Moon Project. Now, the Moon Adventure Project also has one other person in it, only it's just his voice. He's the only one in it. That's me. I'm behind the scenes. And just so you know, this is about a 26-minute video. So we're going to show you the video. Again, shout out to NICE, the National Institute for STEM Education. They provide us lots of really fun stuff over the years here at the Headwater Science Center, and this is one of those. So I'm going to click it. Let Angie go ahead and show you how to do this exhibit.
without further ado, I will have Lee begin.
Welcome. Once you enter this space, you will be on the moon. Welcome to the lunar South Pole. You know, the lunar is another word scientists use when they talk about the moon. You will play astronauts living and doing research on the moon. I am located back here on mission control. So you can ask me questions if you want. You can even put them in the chat box for our different streaming devices. So look around. Everything you will need is here on the tables. Survival of the moon, on the moon, is required in teamwork. All right. Your lunar outpost is up and running. Your oxygen tanks are full. It's time to get to work. Doing research on the surface of the moon is hard work. Fortunately, your team has a remote control rover that can explore the lunar surface. So get started. You'll need to send a rover to specific locations on the moon to collect data. Fill out your rover travel plan to complete your mission. So, there you go.
So the first thing I'm going to do is check out my handy dandy binder full of maps where we can send our little rover. So here, this is just the south pole of the moon. Here we have the actual, this is the detail. This is the Faustini crater that we are going to be exploring. So we've got some maps that show visible light, places that are always in shadow. We've got a map showing the topography or the elevation. This one is showing us the different temperatures. And then we have a couple maps that are kind of giving us a size comparison. So we can see how big the crater is compared to places like New York City or Detroit, Michigan, and things like that. All right, so on my rover travel plan, the first place I'm going to send our rover is the coldest place on our crater rim. So I'm going to go through my maps, and I want to know, let's see, which one is going to give me the answer that I need, the coldest place. Shadows, well, shadows might give us an indication. Topography, not really. Here we go. Average temperature. So I'm going to look all along the crater rim, and I'm going to try to find the coldest spot. So I'm going to look down here where we've got our temperatures. Red is the hottest, goes down to blue, and the very, very coldest is pink and purple. So I'm going to look here, and I'm going to find the coldest spot on the rim. So here's the coldest spot on the entire map, but the coldest spot on the rim looks like it's going to be right here. So I'm going to find those coordinates by going straight up and straight over. So the coldest spot on the rim is at D3. All right, so there's our first clue, and I'm going to write it right here. So you've got D3. Now our next question is the warmest place. All right, so we can stick to that same map. I'm going to keep looking at our dotted line representing the rim, and we're going to remember down here our colors. Red is the hottest, and there we go. That red spot right on the rim. So we'll find our coordinates. We are at D again. This time we're going to go over, and we're at 7. So D7 is the answer to that. Now we were looking for a 10-kilometer wide crater inside the main Faustini crater. So we might be able to kind of guess where that might be based on temperature, or we could probably even do it based on shadows. But what I'm going to do is I'm going to use our topographical map because that shows us elevation, and I'm going to look for a crater inside the main crater. And it's kind of, there we go, right there. So we're going to do our same coordinate thing. We'll go down, we've got the letter E, and we go over, we've got the letter 4. So E4 is the location. I'm sorry, did I say E or D? E. E4. All right, so these are the 3 locations that we have sent our rover to get some information, some data. And now that we've gotten that, we're going to return to the lunar outpost where we are hanging out. So let's go back to our maps and see if we can find a good spot. Well, let's see. So if we look really carefully, there's a tiny little X, and that is indeed where our lunar outpost is. We'll do the same thing. We've got our coordinates of F and 2. All right, so I'm going to write those down. F2. All right, so now we can move on to the next step.
Mission Control has detected some strange seismic readings from the outpost sensors. Have you felt the ground shaking? Let's explore more. Fortunately, your rover just collected some seismic data that we can compare to the outpost sensors to find out what is going on. Match each data block to the exact location where the data was collected to decode a message about the seismic data. Start off by matching the data location overlays to the lunar crater map.
So the first thing I'm going to do is
And just interrupting Angie because we're moving on to the next thing. Yeah, there was an earthquake. You saw that whole thing happen. And we'll continue right on with the show. Just want to mention, thank you very much to Beltrami Electric Cooperative for underwriting today's show. They gave us a generous donation through their Roundup program, and it's really nice to have you out there supporting us. Just wanted you to know, we open Fridays, Saturdays, Sundays, and Mondays. Sunday is right after lunch. It's from 1 to 5, whereas Friday, Saturday, and Monday is 9:30 to 5 o'clock. And the really good news is we're going to go 7 days a week starting on June 4th. Mark that one on your calendar. Go over there and say Friday, June 4th. We are not going to tell you which days we're going to be open anymore because we're going to be open 7 days a week. So enjoy the rest of the show. Angie's going to take you through all of the rest of the stations on the Moon Adventure project.
I'm going to use our numerical data, and that is going to unlock our rover data bank. So we've got the numbers 3, 7, 4, and 2. And so I'm going to use.
We have Angie doing the combination. She's now opened the padlock.
Envelope. And here we have our locations, our location data. So they're kind of see-through. They've got some symbols on there. And we can also see that they have outlines of different craters on the surface of the moon. So let's take a little peek at this. Is all my stuff away. Close this. This is a very nice high-resolution image, and we're going to try to match these up to this surface. I've done this many times. I should have it memorized, but I'm sure I don't.
Oh, so you're saying a person could actually do this exhibit more than once?
Yeah, I think you could maybe do like a time trial, see if you can solve it the fastest.
Just for our listeners' information, this is a new exhibit. It's been up about 2 months. Dan, do you remember where this exhibit came from?
This exhibit came from an organization that is called NISE-Net. And NISE-Net gives out really, really great stuff, lots of hands-on activities, and we love them because they give us cool toys like this, and then we get to take these cool toys and games out into the community. And many of these are designed in a way where, you know, even if you didn't have all the fancy equipment like we have here, you could still do it. Actually, a lot of our 3:30 shows, at least the ones that I do, are NISE-Net stuff. All right, getting closer.
I hope one of them are listening on YouTube or Facebook right now, and then they would have heard that, and they'd go, hey, we gotta get some more things up there. So, Headwater Science Center in Bemidji, Minnesota.
All right, so I've overlaid my doodads. Now I'm going to take my data blocks, and we'll notice that we've got a symbol on the top, and we've got some letters all the way around, and there's also this little marker right here. So just as an example, I'm going to match this shape with that shape, and then I'm going to match this little arrow with this little arrow. So they'll be sitting like this.
I'm going to zoom in so close that it probably won't even show you anymore.
I don't.
Well, show everyone else exactly what you're doing. So here we are. Pretty close.
All right.
Remember, we're on the moon right now. That's what we're doing. Astronaut. Exploring the moon's surface. And you said the south pole of the moon, didn't you?
We're on the south pole of the moon, which is something I never really even thought about until we unpacked this. And I mean, you know, obviously the moon has poles, but I had never considered it. All right, so now we have matched our location data with our data blocks. And so now what we're gonna do is we're gonna look at these blocks and we're gonna see if we can find a code. And so we're gonna do that by looking straight on.
Yeah,
and I don't know if the camera's gonna be able to see it.
If you're a listener out there, you might have to get really close to the screen, but yep, you can see it.
All right, so I'm gonna look at, and now, okay, so here's another thing. This is built to be bilingual, so there's Spanish and English. So we'll notice that we've got black and white letters and like blue and white letters. So the black and white are gonna spell a word in English, and the blue and white will spell the word in Spanish.
Okay, that's helpful.
Give everyone just a second just to look and see.
Oh,
Now, Lee, I know you've been practicing Spanish. Can you find the word on the bottom?
Yeah, but I would have to give my best shot at pronouncing the bottom one. Alerte? Alerta.
Yes.
Alerta would be the Spanish word.
And alerta in English is danger. All right. Not all
There
right.
you are. Danger. All right, first things first. You need to fill your breathable air supply.
We're running low.
You're having difficulty breathing, that must be the danger. Automatic emergency systems have patched the oxygen tanks, but they're almost empty. You'll need water to produce more oxygen to breathe. Luckily, your outpost has a supply of frozen lunar materials. Deep, dark craters. Use the grabber tool to separate the ice from the rock and move the ice into the water extractor. Be careful, the lunar material is dangerously cold. Remember, teamwork.
All right, so here is some dangerously cold lunar material that I'm not really interested in. But here we have our ice blocks. So we are going to use our ice blocks because ice is water. So we're going to use these ice blocks to create some water by putting them into our handy dandy water extractor of science.
Oh, I can see there's more than one extractor. That's because teamwork. We could be using teamwork if only there was another person in the science center right now. So you could do this as a team going through this entire exhibit.
Yeah. Alright. Our water extractor is kind of old, definitely had a warranty. So sometimes you got to give it a little wiggle for actually sending material out. We'll put one more in and see. There we go.
There's the
Hooray!
water extractor. All right.
I have 3 beautiful test tubes of fresh, clean water.
Good job. Now that you have water, you can use the emergency oxygen supply kit to begin producing air. Water molecules can split into hydrogen and oxygen in a process called electrolysis. Did I get that right?
You
Did I start
did.
again?
That's a big word.
Yes, electrolysis. But wait, looks like the shifting, shaking equipment has mixed up the instructions. Recognize the instruction card and build your electrolysis machine.
All right. So, got my water. And this is my emergency kit. So, inside we've got a funnel. We've got a mixing device. We have a graduated cylinder. We have some MgSO4, aka Epsom salt. Got some wires, a battery, a scooper, a stir stick. Here's our instruction cards. And some little metal washers. All right, so let's see. This is a molecule of Epsom salt. Here is a molecule of water.
Yep, H2O.
H2O, one of the probably most famous chemical names. All right, and here's sort of a picture of electrolysis. So we're breaking the hydrogen and oxygen atoms apart, and then the oxygen atoms immediately stick back together, making O2, which is what we breathe. All right, so I've got my cards all mixed up. So, to create electrolysis, the first thing we're going to do is measure 100 milliliters of water that we got from our ice and 1 scoop of Epsom salt. After we measure, we're going to pour them together and mix them. After we get it all mixed, we're going to hook our battery up to those little metal washers using those wires. And then we're going to plunk the washers into our water and Epsom salt mixture, and we're going to see if we can notice some little bubbles. All right, so the first thing, I get my scooper.
This is Epsom salt. She's putting it into the, looks like a measuring cup cylinder.
All right, now
And some water.
I'm going to measure out some water.
Scientists call it water, they call it H2O.
Some dihydrogen monoxide.
Oh, all right.
If you want to sound crazy.
It sounded really smart.
But it means the exact same thing as water.
Di meaning two?
Yeah. So
Okay.
dihydrogen meaning 2 hydrogens, and mon is short for mono, which means 1 usually. So dihydrogen monoxide. All right, so we've got our water
You can
there.
say H2O.
We can sure say H2O. Okay, we'll pour that in there.
Wow.
Then we're gonna mix, 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 mix. Mix all.
Is there a chemical reaction occurring there?
Right now, so chemical reaction, usually when we hear that word, we think of like, I'm gonna mix 2 things together and something crazy is gonna happen. There is a reaction happening right now. It's called dissolving. And so what's happening is water is what we call a universal solvent. So how deep do you want to get into it? So water is what we call a polar molecule. And that means one end of the molecule is positive and one end is negative, sort of like a magnet. And what happens is if you pour or put another substance into water, what'll happen is it'll start to kind of like pull them apart. And when those molecules get pulled apart, we call it dissolving. So that's why I can stir salt or sugar in water, and eventually you won't be able to see the granules anymore because they kind of break apart and hang out in between the spaces of the water molecules. All right, so I'm going to say that's well enough mixed. Flip that there. Flip this here. All right, now this is the hard part because our clippers don't ever want to stay clipped.
You're attaching it to the battery now.
So now we're going to put these on the battery. And
Now that they're both attached to the battery.
so I'm going to pop them in here. And oh, almost had it. No, if you can see from that far away, but our clips and our washers they look like they're fizzing, and those tiny little air bubbles are bubbles full of pure oxygen that has resulted from electrolysis. So the electric current is breaking those water molecules apart, and the oxygens are coming together and fizzing up and bubbling away. So if we do this on a large enough scale, eventually we will be able to refill our oxygen tanks. All right.
The danger isn't over. The backup batteries won't last much longer. You need to reconnect the outpost to its main power supply. The moonquake damaged the connecting wires. So you'll have to figure out how to connect the circuit. You will need to get creative with the materials you have, even if the solution is just temporary. Once the circuit is complete, Once the circuit is completed and the electricity is flowing again, you will hear that the system has restarted.
All right. So here is our dashboard, shall we call it? And here's a whole bunch of supplies. We've got pencils, spoons, chopsticks, rulers, knives, paintbrush, another knife. Let's see. So here's all of our stuff that we have to repair our console. There's two things we have to think about. And the main important thing is to know the difference between a conductor and an insulator. So a conductor allows electricity to flow where an insulator does not. So if you've ever looked at like power lines, the wires will be made out of a conductor, but a lot of times there's little glass posts that sort of stick up that the wires sit on, and those little glass posts are there, and they're made of glass because it's an insulator. It doesn't allow electricity to flow. So that's why you want to wear like a rubber boots if you're working in water and electricity. All right, so I digress. Plastic, not a conductor. Wood, also not a conductor. Metal, that's the classic conductor that we all think about. So we've got some metal pieces here. Rubber, not a conductor. Let's see, this is a wire. Oh, this is a really good example. So here's a wire that is a conductor, but it is covered in rubber that is an insulator. That way, when the current is moving through this wire, I can touch it without getting electricity, or without getting electrocuted. Fun fact, maybe not so fun fact, humans, we're conductors. That's why it's important to be careful when you're outside during a storm, because we will conduct electricity. And when that happens, you get burns, you get holes poked in your organs, and it's no fun. So this has a little bit of metal, but it's mostly wood, so I don't think that's gonna work. This has metal, but again, got some wood, so I don't think that's gonna work. So basically, I've got all my metal pieces, and then we've got these pencils. Pencils that are made of wood, but the inside is made of something called graphite, which is a conductor, but because they're so pointy, it's really hard to get it connected. So, let's see. I'm gonna go with a nice handy wire. And let's put the wire to a metal spoon. I've got my big magnetic doodad. And this other wire here. All right, if it worked, we'll get some noise.
Congratulations, awesome work, great teamwork. You survived the moonquake. You restored power to the outpost. Now, you have successfully completed the mission. That's our show for today. Angie successfully gets to come back to the Earth. Thanks for watching today. Again, we've given them a couple of shout outs today, but big thanks to NISE, who provided this particular exhibit for us. It's currently not on our floor. We've taken it down for the next few months, but we will provide it for you again maybe next winter, or if we were to go out to a school or something like that. So thank you very much for that from NISE. And thanks again to Beltrami Electric Cooperative for underwriting our show today. And looking forward to seeing you back here. Make sure if you're a guest or visitor, you're coming this Friday, Saturday, Sunday, and Monday. And then again, we are going 7 days a week once we get to June 4th.